Hello and welcome, I'm Hoyeon Kim, and in this video I'll present our work ChimeraLoRA, Multi-Head LoRA-Guided Synthetic Datasets. This is joint work with my collaborators from the Machine Learning Lab at Postech and Naver AI Lab. Let me begin by motivating our problem. When we train a classifier with balanced and abundant data, the model wants a decision boundary that aligns well with the underlying class structure. In practice, however, training data is often imbalanced and limited to only a few images per class. In this regime, the round decision boundary becomes skewed toward the majority, yielding a biased classifier whose predictions are no longer trustworthy. This is not merely a theoretical concern. Specialized domains such as medical and satellite images often suffer from limited data due to acquisition cost. Likewise, long-tail distributions are pervasive in species and object classification, where rare categories are severely underrepresented. A natural approach is to supplement the missing data using generative models. Pre-trained diffusion models such as Stable Diffusion can synthesize images from a text prompt alone in a zero-shot manner. Yet, zero-shot generation has well-known weaknesses. First, it suffers from semantic misalignment. The prompt of a port of a BASS may produce a fish instead of a guitar. Second, it incurs distribution shift. Generated handwritten digits look stylistically different from real MNIST samples. To overcome these issues, recent work introduced few-shot guidance by fine-tuning the diffusion model with LoRa adapters on the available few-shot real images. For example, image-wise guidance trains a separate LoRa for each individual image, while class-wise guidance trains a single LoRa over all images of a class. Each strategy, however, has its own limitation. Specifically, image-wise LoRa achieves high fidelity but offers low diversity. Class-wise LoRa, by contrast, captures broader classifiers and offers high diversity but loses fine-grained details. Our goal is to combine the benefits of both methods, achieving high fidelity and high diversity simultaneously. We introduced a multi-head LoRa architecture. We decompose the adapter into a shared LoRa matrix A, which encodes class-level priors, and multiple per-image LoRa matrix B, each capturing image-specific characteristics. To preserve coherent semantics during training, we apply semantic boosting using grounded SEM to extract object bounding boxes, ensuring the shared adapter focuses on the target object. At generation time, we compose the shared LoRa A with a mixture of the per-image LoRa Bs, using mixing coefficients sampled from a Dirichlet distribution. This Dirichlet weighted merging allows us to interpolate smoothly across the few-shot images, producing synthetic samples that are both faithful to the class and rich in variation. To assess the quality of our synthetic data, we analyze the synthetic-to-real gap from two perspectives. Qualitatively, we visualize real and static images using t-SNE. Our synthetic samples show tight within-class alignment with real images while preserving clear cross-class separation. Quantitatively, we measure two standard metrics against the few-shot real reference, FID and Cray-score. Here, ChimeraLoRa achieves both the lowest FID and the highest Cray-score among competing methods, implying the lowest synthetic-to-real gap. In addition, we evaluate downstream classification tasks trained with synthetic images. In the few-shot scenarios, including medical and satellite domains, our method constantly outperforms previous methods. In the long-tail scenarios, we observe the same trend. These robust gains demonstrate the practical utility of our synthetic images for data scale settings. Here are three takeaways. To summarize briefly, we propose ChimeraLoRa, a multi-head LoRa diffusion framework that generates diverse and high-fidelity images for improving few-shot and long-tail classification. For more details, please check out our paper. Thanks for watching.